In this lesson, we are going to be looking at congruent parts. So let's go ahead and figure out what the corresponding sides and angles in figures have to do with their congruence. So in this first activity, you're just going to do a notice and wonder. So you can pause, see what you notice, see what you wonder about the four shapes on the screen. So this is on page 170 in your student workbook as well. You won't have the color in your student workbook, but you see it on the screen. So let's take a look at some things that people noticed and wondered about these shapes. Maybe you noticed and wondered the same things. So some notices that this first one is blue. Okay, the only blue one. So whether that was a notice or a wonder, like it's only blue, noticed it, or wondered, why is this one blue? Could have been something you said. Maybe you noticed in this one that it looked like it was a reflection of A. So it looks like it's a reflection of A, kind of down a line right in between here. So reflection of A. Maybe you noticed that D was a rotation of A. Maybe you noticed that the blue one was the only one with the letters and not the prime notation. So then maybe you notice the other one's had prime notation. Maybe you noticed that the order was flipped of the letters here. So here it went P, Q, R, S. And so here it went P, Q, R, S counterclockwise. P, Q, R, S from the bottom here. And then in figure C, it's the only one where the order is not P, Q, R, S. So it goes P, R, Q, S. And certainly could have noticed some other things. Does figure like why is the order like that? Is there a transformation that takes A to C? So we saw a reflection that took A to B, a rotation took A to D. Is there something that takes A to C? Anything like that? All right, in activity 2, we're going to look at two congruent triangles. So we are telling you in this thing right here, this is called a congruence statement. So telling you that triangle ABC is congruent to triangle DEF. This is on page 171 in your workbook. So you're going to take a little bit of time here to work with your small group and work through numbers 1 through 4. You can pause the video, come back, and I will synthesize what small groups talked about. Okay, so you were supposed to find a set of rigid transformations, so a sequence of rigid transformations. So let me just draw this triangle on here so that as I do my rigid transformation, you can see it moving over to the other triangle. All right, so find a sequence of rigid motions that takes triangle ABC to triangle, and this got cut off, but to triangle DEF. Okay, so then that means that I want A to go right onto D, B to go onto E, C to go onto F, so in that same order. So maybe you said could be a reflection over the perpendicular bisector of BE. So if we were to get the perpendicular bisector in there of this, so we've got like a right angle here. and know that this piece is congruent to this piece. So if you constructed the perpendicular bisector, that would flip it over. Okay, if you weren't gonna, say about the construction of the perpendicular bisector, you can translate. Okay, so we could translate B to E. So translate, let me type that out. So we could translate triangle ABC on directed segment BE. So taking B to E. So then that gets us here. Then we could rotate around point B until A coincides with D or lands on top of D. Okay, so if I then rotate this, keeping B in the same spot, so keeping B on E, rotate here. Okay, that lines up AB with DE. So then we could reflect ABC over line DE. So then I would just flip that over this one, and then that would land C onto F. So I'm just gonna quick get that flipped here. So then that would flip that on there. So translate B to E, rotate around point D until A lands on, around point E until A lands on D, then reflect over DE. So what is the image of BC? So where did BC land on this on triangle DEF? So where did BC land? It landed on EF. Explain how you know those segments are congruent. Because EF is the image of BC after a sequence of rigid transformations, and rigid transformations keep the same shape and size. So the image and the original figure need to be the same size. And then justify that angle ABC. Okay, so that angle ABC is the same size as angle DEF. Okay, and again, so we see ABC is the original and DEF is the image. Okay, so that translated right onto there. So again, it's going to be this kind of same justification here. Okay, because angle ABC, because angle DEF is the image of angle ABC after a sequence of rigid transformations. Has to hold the same shape and size. Okay, so then you have a reference chart, and so this can get filled in on your reference chart for lesson 1 of chapter 2. So corresponding parts. If two figures are congruent, then the corresponding parts of those figures must be congruent as well. So what we end up with is the sides. So we just saw how a side will translate to another side, and how an angle will translate to transform into another. So you'll have the original figure and its image. So all of those corresponding parts are congruent. You can see this from the congruence statement. So when they give you this congruence statement, it will give you all the corresponding parts. So we have triangle PQR is congruent to triangle DEF. You will be able to get the angles and the sides from this that are corresponding. So for the angles, it's these letters. So angle P is going to be congruent to angle D because they're both in the first position. Angle Q is going to be congruent to angle E because they're both in the second position. And then angle R is congruent to angle F because they're both at the end, or they're both in the third spot. So that congruent statement is going to tell you that. Same with the sides. So we name sides by 2 letters. So this is side PQ. You're going to be able to get that from this congruent statement. So PQ are the first 2 letters congruent to DF, the first 2 letters in the next triangle. QR, EF, because they're the last 2 letters. Okay, and then the final side, so we've got the PQ, the QR, PR, so first and last letter. First and last letter. So PR is congruent to DF. So this statement will get you the angles and the sides that are corresponding. So they're corresponding in the same spot on the congruent statement and the same spot on the shape. Okay, so if I were to take this shape and move it down, P, Q, R, move it to the other shape. Okay, you would see PQ landed with DE, QR with EF, PR with DE, angle P and D, angle Q and E, angle R and F. So those are corresponding parts. And they need to be from congruent figures. All right, activity 3 here is on page 172 in your workbook. And so it says identify, so work through these directions here, okay, and answer these questions. You can pause the video and then come back. So it says draw a triangle, so any triangle. Okay, and then it says find the midpoint of the longest side, so determine which side is longest. So I'm just gonna kind of make this a little bit different here. Okay, so determine which is your longest side. You can use a compass or whatever you need to figure out which one's the longest. And so then it says find the midpoint of the longest side. So however you're doing that with a ruler, folding your paper in half, getting some tracing paper, but find the midpoint of that side. So remember, if you're folding, just fold this vertex onto this one so that you fold the segment in half, and then you can identify where that midpoint is. Then it says rotate your triangle 180 degrees using the midpoint of the longest side. So we're going to take and rotate this triangle. So tracing paper, just rotate it around. And really the 180 degree rotation is just going to match up your vertices. So even if you don't have the midpoint exactly correct, okay, you're just going to rotate. It'll keep these 2 vertices the same. Okay, so just sketch the triangle, rotate it around, and then get that sketched onto your paper, and then label the corresponding parts. So let's label the first triangle. So make sure you have the first triangle labeled. So now this is going to rotate over. This is going to be C prime. This is going to be A prime. This is going to be B prime. So I rotated that triangle around. And mark what must be congruent. Okay, so go ahead and mark up the angle. So I'm going to put an angle mark here to go with this angle. An angle mark here with 2 ticks, that's going to go with this one. An angle mark here with 3 ticks, that's going to go with this angle C prime down here. We also know corresponding sides are going to be congruent. So I know this side is going to be congruent to this side, AB to A prime B prime, B prime C, or sorry, BC to B prime C prime. So what type of shape did we just get? Okay, so we just definitely got a parallelogram. And what's the definition of the shape that you decided that you got? So of a parallelogram, it's a quadrilateral, so a four-sided figure with both pairs of opposite sides parallel. So why must this one fit that definition? Well, when we do a 180-degree rotation, which we did around this midpoint, it forces the image, the original figure and its image to be parallel to each other. Okay, so that 180-degree rotation forced this side to be parallel to this side and also forced this side to be parallel to this side. So that gave me those opposite sides parallel. Okay, so because of the definition of a 180-degree rotation. And that's on your Unit 1B reference sheet. So if you look back to that, you can see that. Okay, so then for your lesson summary. So you can kind of read through this as summarizing what we talked about today. And so if you take a look, I mean, corresponding parts was a big part of today's lesson. That could be, you know, a corresponding part could be an angle. It could be a point. It could be a side. Okay, so point C is corresponding to point F, or angle B is corresponding to angle E, or side AC is corresponding to side FD. So those are just a couple different corresponding parts there. Then if the two figures are not congruent, okay, that means there's not a rigid transformation. So we saw if the two shapes are congruent, then there is a rigid transformation that can take one to the next. If they're not congruent, then there isn't a rigid transformation. Okay, so if they are congruent, there is a rigid transformation. And so then this next part just says the same rigid transformation can also be applied to individual parts. So if we just wanted to translate one part or rotate, reflect one part to get one angle on top of the other, okay, that would also be possible. And then it would, if you're moving an angle, then it's likely that it's going to get the whole figure to land on top of the other one. Otherwise, you could just sometimes translate a segment to notice that they're congruent before you get the whole shape to land on top of each other, like we kind of saw in this one. So before I flipped this, so let me flip it back. Right, we were able to just translate B to E and then rotate. So you got side AB matched up before we got the whole figure matched up. And then knowing that corresponding parts of congruent figures are congruent will help prove that two line segments or two angles are congruent if they are corresponding parts of congruent figures. So we did that when we talked about here, not this one, sorry, when we talked here about what's the image of BC, how do we know? So being able to say that the rigid transformation made that possible. All right, here's a list of learning targets that we did today. I can identify corresponding parts from a congruent statement, use rigid transformations to figure out if figures are congruent, and write a congruent statement. And then this would be a cool down from this lesson. So triangle A prime, B prime, C prime is a reflection of ABC across line BC. Prove that ray BC is the angle bisector. So proving that AB is BC, that this is the angle bisector. So thinking about what that means, if it's an angle bisector, it means it splits this in half. So it means that these two angles are congruent is what you're trying to prove in that. So how can you prove that that this angle here, angle ABC, okay, so angle ABC is congruent to angle A prime, B prime, C prime, is what you're trying to put language to. So how could we prove that? Because A prime, B prime, C prime is the image after a reflection of angle ABC. So by definition of a rigid transformation, those angles need to stay the same.